Timber grades play a crucial role in Australian construction, influencing both the strength and suitability of materials used. Understanding these grades helps ensure that the right type of timber is selected for specific applications, which can significantly impact the durability and safety of a structure. This guide will delve into the various timber grading methods, providing insights into how they affect construction practices and outcomes. Hello everyone, it's Tariq from MTS Consulting Engineers, and today I'll be talking about timber grades in Australian construction. Starting off with a brief introduction to structural grading, also known as a stress grading, is the process by which timber is categorized into groups, or a stress grades based on its structural properties, specifically its strength and rigidity. And this is to ensure reliable and predictable timber performance in construction. The methods include visual stress grading, machine stress grading, and machine-proof grading. However, in Australian construction, timber is graded using either visual F grades or machine stress grading MGP grades. Machine-proof grading has very limited use. To ensure reliability, rules for acceptable sorting methods have been established. In many countries, including Australia, these are often industry or national standards. These standards grade timber and are often referenced in materials specifications. Engineers and architects need basic knowledge of visual stress grading for site inspections and BCA certification. Visual stress grading, or F grades, is a method that assesses timber based on its strength. The table outlines common F grades, such as F5, which is suitable for general framing, and F7, which is ideal for areas requiring additional support. Higher grades like F14 and F17 are designed for more demanding applications, capable of withstanding greater pressure. Understanding these grades is vital for selecting the right timber for specific structural needs. Machine stress grading, MGP, is another important grading system that categorizes timber based on its structural and stiffness. MGP 10 is typically used for residential framing, while MGP 12 and MGP 15 offer increased strength for more demanding applications. Notably, MGP grades corresponds to F grades, with MGP 10 equating to F7, MGP 12 to F8, MGP 15 to F11. This comparison aids in selecting the right timber for various construction scenarios. To know how much a piece of wood will deform under stress or how to predict the stiffness and deflection of timber beams, we need to measure its modulus of elasticity. In the simplest term, the modulus of elasticity measures a wood's stiffness and is a good overall indicator of its strength. Technically, it's a measurement of the ratio of stress placed upon a wood compared to the strain or deformation that the wood exhibits along its length. It is a crucial factor understanding timber performance. It measures the stiffness of timber, which is essential for ensuring structural stability. This slide compares the modulus of elasticity, or MOE, values for different grades of F and MGP materials. For instance, F5 has an MOE of 6,900 MPa, while F8 and F14 show higher values of 9,100 MPa and 12,000 MPa respectively. On the MGP side, the MGP 10 starts at 10,000 MPa, with the MGP 12 and MGP 15 reaching to 12,700 MPa and 15,200 MPa. These differences in MOE are crucial for understanding the performance characteristics of these materials in various applications. Higher MOE values typically indicate a stiffer material, which can be beneficial in structural applications where load-bearing capacity is essential. This comparison helps in selecting the appropriate material grades based on its specific engineering requirements. In addition to F grades timber and MGP timber, we also have seasoned and unseasoned timber. Seasoned timber is dry timber with reduced moisture content, while unseasoned timber or green timber has a higher moisture content. Seasoning improves timber's stability, strength, and resistance to decay. Unseasoned timber can shrink, warp, and making it less ideal for many applications. Unseasoned timber is graded from S1 through S7, and with S1 being the strongest, while seasoned timber is graded from SD1 through SD8, with SD1 being the strongest. Seasoned timber with reduced weight, improved strength, and stability is particularly beneficial for indoor applications where dimensional stability is crucial, like in framing, flooring, and interior joinery. In addition to grading, several key considerations affect timber selections. Factors such as timber species and their durability ratings, as well as treated timber classifications like H2, H3, and H4, play a significant role in ensuring the longevity and safety of structures. Additionally, the presence of gum vein can impact grading, making it essential to consider these elements when choosing timber for construction. Consider H3 or H4 treated timber for outdoor structure and H2 treated point for indoor use. Gum veins are the buildup of tree saps or resins, and their size and number can affect the timber grades. As we conclude, it's important to recap the key takeaways regarding timber grades and their implications for construction. Selecting the right grade is not just a matter of preference, it's crucial for meeting specific construction needs and ensuring structural integrity. By understanding the various grading systems and their implications, we can make informed decisions that enhances the quality and safety of our building projects. I'm going to end this presentation by saying build right, build safe, and build compliant. Thank you very much. I'll see you at my next presentation. Bye.